Hello everyone, this is review video for KSAT, which stands for Korea Scholastic Aptitude Test, math test especially. This time I want to review the KSAT math test admission year 2024 geometry optional subject. This is odd time number 30. This problem is about vector, and that's all. You construct a geometric figure which satisfies those all conditions here, and you manipulate some parameters or values, and then you find some specific conditions which satisfy this condition here, okay, and construct the triangle. That's our final goal. Let me give you 2 points which characterizes this problem. The first one is to set coordinates. It's for dealing with vectors. The coordinates gives us the specific values and specific picture for vectors. Okay, so in this case we have an equilateral triangle whose common side, length of common side is 4. Let's say A, B, C here. It is equilateral triangle. For the convenience, I set the x coordinate here and y coordinate here, passing through the point A, and then we have a coordinate here 2 and -2. For the coordinate of point A, we have 0 for x coordinate and 2 times square root of 3 for the y coordinate, because as you know, in case of right triangle whose one acute angle is pi over 3, the length of sides has a ratio 2 versus 1 versus square root of 3. It's a ratio 2 versus 1 dash is square root of 3. This is the longest one and this is the shortest one. Okay, and then second point for this problem is that how to deal with those let's say those actually three, because the x is determined by the position of p, q, and r. So it has 3 independent vectors. So how to deal with let's say pb, qc, and ra vector. How can deal with those 3 vectors? Is it overwhelming me to deal with it, or we can find some rule which makes this vector, magnitude of this vector is maximum. Let's see this. later. As you can read, we have extra points, 3 points, D, E, and F, which are all internal points. The ratio is 1 versus 3 here. It is D. Let me choose a different color. D, E, F. The ratio is 1, 3. Is 1. It's actually -1. We have a specific coordinate here. It's 1, 3. Okay. First, let's figure out each coordinate D and F. E is simple here, but in case of D, we have coordinate. We have some coordinate here. In the F, we have some coordinate here. Since the ratio is 1 versus 3, 1 plus 3 is 4, we divide x-axis by 4, 1, 2, 3, 4, and its x-axis is -1/2. Also, we divide the y-axis equally by 4, and each segment has a length of 2 times square root of 3 over 4, which is square root of 3 over 2. So this is 3 times square root of 3 over 2. This f is likewise, this is 1/2 before 2, 3/2, and square root of 3 over 2. Okay. And then let's see the condition A. Condition A means that the length of point P from point D is 1. It means point P is on the circle centered at point D with radius 1. It's the same for the other cases. For the point Q, it's on the circle at the centered point E with radius 1. Point R is on the circle with radius 1, which is centered at point F here. So those P, Q, and R, they can move independently. So basically we need 3 parameters to express those 3 points. The next question, how to deal with this condition. So the vector AX is determined by the position of PQ and R, which are all mutually independent. It's a sum of 3 vectors. How can deal with this condition? Here I think this is the main point of this problem, and we have to use a specific one first and derive some ambiguous one later. The specific one is that we do know the coordinates of D, E, and F. We have a specific coordinate. So in case of vector PB, is it PB? PD. I'm sorry. I'm sorry. Just ignore. PB is right. So In the case of vector PB, it will look uh, like this from P to B here, but we can detour it, like for instance P goes to D first and then goes to B. So let me rewrite it. P goes to D first and then from D goes to B, like here. Likewise, for the QC is a vector like this, but we can go to point E first and then go to point C. So QE plus vector EC, and then likewise RA here, we can go from R to F first and F to A later. R to, let me change color. R to F first and F to A later here. We can express like this. As I said, the specific one we have is the coordinate vector of DB, the second one, and EC, the second one, and FA, the second one. Let me express those three as a coordinate. So for the vector DB, is a coordinate B coordinate minus D coordinate, negative 1/2, comma 3 times square root of 3 over 2, which is negative 3/2, comma negative 3 square root of 3 over 2. In case of, likewise, you can do this. The coordinate EC is coordinate of point C minus coordinate of E, which is 3, 0, and for the vector FA, it's a coordinate of A minus coordinate of F, 3/2, comma square root of 3 over 2, which is negative 3/2, comma 3 times square root of 3 over 2. Okay. And after you add them up, those three vectors, you will notice that their vector coordinate is 0, 0, so they do not contribute. So let's rewrite it. They all disappear. They do not contribute, which is said in vector vocabulary. It goes to somewhere and then it goes back to the original start point. It goes back to the start point, so it does not contribute. So vector AX is actually sum of three vectors, PD plus QE plus RF. This is the first one. So all the three vectors are, it's like a clock needle, 3 clock needle with same radius one. Okay, and they move independently. So to make the magnitude of vector AX maximum, it is always hold for this inequality here. It's a triangular inequality here, which is 3, because each of them, their magnitude is 1. So when the magnitude becomes 3, it is when those 3 vectors are all parallel and denotes the same direction. For instance, they can be like this, same direction, or they can be like this, or they can be like this. You have infinitely many cases. They can be like this, and so on. So choose the simple one. I'm gonna choose this case here. Let me simplify the picture for the last step here. We have an equilateral triangle A, B, and C. And I set the origin here. This is X coordinate and this is the Y coordinate here. And we have 4 points D, E, and F here. Okay. And we do have a specific coordinate here. 3 times square root of 3 over 2. So negative 1. This is a negative 2. This is a 2, 3 half, square root of 3 over 2 here. Okay, and draw the circle with the radius 1 here. I'm gonna choose the parallel 3 vectors denoting the same direction here. It's a D, it would be PD. So this one P. So PD and QE. This is QE, like, and then this point is RF. They are all +1 X coordinate, and there's no difference for the Y coordinate here. Q is the origin here. The point R is 5 over 2 comma square root of 3 over 2. Okay. So if you draw triangle PQR, it will look like this. And we are interested in the area of triangle PQR. You have the coordinate. Basically, you can compute its area. In my case, if I were you, um, I'm gonna expand this line segment PQ, PR, this line segment PR, and we have x-intercept here from P to R. P to R here, R is here. We have to go from P to R. We have to go 1 here. I'm sorry, I was wrong here. This should be negative 1/2, and the coordinate for P should be positive 1/2. Okay, it's a negative sign here. So from P to R, we have to go like this. We have to go positive 2 for the x-axis here, and then we have to go negative 3/2, negative square root of 3 for the y-axis. Okay, like this. So for the x-axis here, the height difference is square root of 2 here. Hence, it just it goes to just 1/2 of it. So this should be 1 here. So the x coordinate for the, let's say, the point is L here. The point L, we go plus 1 x coordinate further, and we go minus square root of 3 over 2 here. So the coordinate for L is 7/2, 0. So the point is, the area S is area difference from the big triangle PQL here, the L is here, minus the extra triangle RQL. So the they share the width here, bottom side, as a QL. So if you compute, their length of bottom side is 7/2, and height is 3 times square root of 3 over 2 minus the height for the second triangle is square root of 3 over 2. So you can reach the value, then 7 times square root of 3 over 4. This is the area of the triangle PQR. Okay, let's wrap up this problem. When we deal with a vector, especially each point lie on some geometric figure like triangle or a circle with a certain radius and with a certain center, we have an extra freedom here to the vector can move freely as long as they satisfy certain conditions. In this case, the reason why students might feel extra difficulty is that they may feel difficulty in dealing with those three independent points and induce some meaning from the condition B, what it means. So if they could use certain information from the coordinate, and we have a fixed point D, E, and F. Let me say they are intermediate point. They are fixed, so all the coordinates are known. If they could have figured out the meaning for the condition B. Otherwise, to get some clue from this equation will be hard, might be hard. Okay, so you have to see the problem in many different ways. Try to see the problem in many different ways. Okay, that's all.